Welcome back, everyone. Today we're going to solve an interesting question in maths, which is also a topic in physics, rectilinear motion. And I'm going to use the principle of calculus to solve it. Watch this video to the end. Let's dive right in. The question says, a particle moves along a straight line so that after a time t second, its distance x centimeter from the starting point O is given by x equal to t cubed minus 15t squared plus 63t minus 40. We are asked to find the distances from O when the particle is momentarily at rest and the velocity when the acceleration is 0. Watch this video to the end to see how the solution is gotten. Let's go. This is what we are given. S is equal to t cubed minus 15t squared plus 63t minus 40. Now, the distances from O when a particle is momentarily at rest, let's get that first. You know that a particle is at rest when the velocity is 0. So from here, this is distance equal to this. To get the velocity, we are going to differentiate x with respect to t because velocity is the rate of change of distance with time. So velocity v is equal to ds over dt, and this is equal to, I'll differentiate each of the terms I have here. Differentiate t cubed to get 3t squared. Differentiate minus 15t squared to get minus 30t. Differentiate 63t to get 63. Differentiate 40 to get 0. So this is v equal to 3t squared minus 30t plus 63. And no worries if you don't understand what I did here. I have a video on differentiation of a sum. So you can go watch that video on my calculus playlist. You see it there and watch. Let's proceed. This is the velocity 3t squared minus 30t plus 63. Now, we are told that the particle is momentarily at rest. That means v is equal to what? 0. So when v is equal to 0, it means that this expression here is equal to 0. That is 3t squared minus 30t plus 63 is equal to 0 because v is equal to 0. Now, permit me to reduce this left hand side by dividing both sides by 3. That is, divided by 3. 3 cancels 3. I have t squared minus 30 divided by 3 is minus 10. I have minus 10t. 63 divided by 3 is 21, equal to 0. So I will solve this quadratic equation to get two values for t. This is t squared minus 7t minus 3t plus 21 equal to 0. Because minus 7t minus 3t is minus 10t. So let's proceed. I'll factorize. What's common to both t squared and minus 7t? I have t. T squared divided by t is t. Minus 7t divided by t is minus 7. Then, I'll come here. This next 2. What's common to minus 3t and 21 is minus 3. Bring it out. Minus 3t divided by minus 3 is t. 21 divided by minus 3 is minus 7, equal to 0. And this means that t minus 7 in brackets and t minus 3 is equal to 0. And you know that if the product of two real numbers is 0, then either of the numbers is 0. This means that t minus 7 is equal to 0 or t minus 3 is equal to 0. And you can say that t minus 7 is equal to 0. It means that t is equal to 7. Or t is equal to what? 3. Or t is equal to what? 3. So we have two times here. 7 seconds or 3 seconds. So we have t equal to 7 seconds or t equal to 3 seconds. Now, the distances from O when the particle is momentarily at rest. We have these two values of t, 7 seconds and 3 seconds. We are going to plug them one after the other into this x equal to t stuff equation to get the two values of the distance. So when t is equal to 7 seconds, the distance is equal to, plug in 7 here, that's 7 to the raised to power 3 minus 15 times 7 squared plus 63 times 7 minus 40. 7 cubed is 343. 15 times, this is 49, is 735 plus 63 times 7, that will be 441 minus 40. So this entire stuff here is equal to 9 centimeters. So when t is equal to 7 seconds, the distance is 9 centimeters. What of when t is equal to 3 seconds? So S will be equal to, I'll plug in 3 into this equation. That's 3 cubed minus 15 times 3 squared plus 63 times 3 minus 40. 3 cubed is 27. 3 squared is 9, and 9 times 15 will give us 135. 63 times 3 is 189, then minus 40. So what would this be equal to? 41 centimeters. So the distances from O when the particle is momentarily at rest are 9 centimeters and 41 centimeters. Let's answer the second question. The velocity when the acceleration is 0. Let's get the acceleration first. Acceleration is change in velocity over time. That's the v dt. And this is equal to, we are going to differentiate this to get the v dt. This is v. So differentiating it gives us the v dt, which is equal to the acceleration. And of course, if I differentiate this t squared, I'll get 6t. Differentiate minus 30t, I'll get minus 30. Differentiate 63, that's 0. So the acceleration is equal to 60 minus 30. We said that the velocity when the acceleration is 0, the acceleration is 0. That means 0 is equal to 60 minus 30. So I'll solve for t in this equation. So we get 0 plus 30 is equal to 60. This is 30 equal to 60. Of course, 30 over 6 equal to 60 over 6. 6 cancels 6. 5 is equal to t. So t is equal to 5 seconds. When the acceleration is 0, the time is 5 seconds. Now, what is the velocity? To get the velocity, we are going to plug in this value 5 for t in this velocity equation. V equal to 3t squared minus 30t plus 63. So whatever answer we get is the value of the velocity when the acceleration is 0. Now watch. So V will be equal to, this is for number 2, 3 times t is 5, that's 5 squared, minus 30, t is 5 times 5 plus 63. 5 squared is 25. 25 times 3 is 75. 30 times 5 is 150 plus 63. So we have minus 12 centimeter per second. So when the acceleration is 0 at t equal to 5 seconds, the velocity is minus 12 centimeter per second. Thank you very much for watching this video. I hope you like it. Subscribe, turn on notifications, tell your friends about the channel, share this video. Drop your comments on the comment section. Let me know what you think about this video. If you have a question, drop it and it will be responded to. Don't forget to subscribe, don't forget to like. I'll see you in my next video.